Okay, welcome back. So we've opened our vector waveform file. We've imported our inputs and outputs, and now what we'd like to do is to group our inputs together. Before we group, again, we need to make sure that the inputs are ordered correctly. In the truth table, A was the leftmost bit, so that needs to go at the top of the list. And your rightmost bit needs to go at the bottom of the list. So that's how it's oriented. We're going to select our inputs, then we're going to right click, and we're going to go to grouping, group. We're going to name the group input. We're going to make sure again that the radix is in binary, and we're going to click OK. And that will collapse our inputs into a nice, easy to read 3-bit number. F is our output. If we had more than one output, we would do the same grouping technique, but since there's just one output, we'll just leave it like that. The next thing that we're going to do is we're going to make sure that we test all the possible combinations. So we're going to click our inputs, and then we're going to count. So we're going to click the count button here. And most of this stuff you can forget about because we're not doing a timing simulation. So we'll click OK. And there we can see that it has counted from 0 to 7 in 10 nanosecond increments, which is not important to us because we're doing a functional simulation, not a timing simulation. And what we want to do is make sure that our output F matches what we had in the truth table. So that would be our completed simulation, and that would tell us whether or not the circuit we've designed in the schematic is correct, and will give us the output that we wanted in the truth table. So now we're going to save our vector waveform file. We're going to make sure that it's saved into the correct folder for this project. We're going to go to Assignments, Settings. We're going to click on it's in here somewhere. Simulator Settings down here at the bottom. And we want to switch our simulation mode from timing to functional. And we should be all set to simulate our circuit. So we're going to click this button here to start the simulation. Alright, it's telling us there's no input file. So this is a problem that happens every now and then. It's probably because I switched the folder in the middle here inadvertently. So we'll go back to settings, and here we can see that there's no simulation input. So I need to point it to the correct file, which is actually right there, which is my vector waveform file. And now it knows what inputs we want during this simulation. We'll click OK. We'll run it again. And OK, so now we have another tab open. So you can see those tabs here. This is our simulation report. It's different than our vector waveform file, although it looks very similar. So the simulation report is here, and we have our output now. So we can look for the correct output. So we have 010 is returning true, which it should, and 111 is returning true, and those are the only two cases that return true. So our circuit design is correct, and we've properly simulated the circuit. Alright, next we'd like to actually put this onto our FPGA. The way that we're going to do that is by looking at the user manual to find the pin assignments. And in this case, we're going to assign inputs to slide switches and outputs to LEDs so that we can see things light up based on our inputs and outputs. So the way that we assign pins is we go to Tools, Programmer, and we should see that we've got, actually, sorry, we need to do our programmer is the second step. We need to do our pin assignments. So we're going to go to Assignments, Pins. There we go. And this is the layout of the FPGA, which we can just ignore. and we want to assign pins. We should get a, oh, nope, don't want that. Little drop-down menu here. And we'll be able to determine what the pins are from the user manual. So I'm going to load up the user manual real fast. Let's see. Alright, so now I've got the user manual open. So I want to assign the 3 switches to S0, S1, and S2, which are down here at the bottom right on the board. And the output at any one of the LEDs. So I'm just going to do LED 0. And so I need to find those pins. A lot of the information in the FPGA is really not pertinent to what we're doing. So the most important pages here are the tables with the pin assignments. So I want slide switch 0, 1, and 2. And that's going from C, B, and then A, because A is my rightmost bit. And that's very important to keep in mind what your right and leftmost bits are. So my my leftmost bit would be A, and that's going to go on pin H6. So I'm going to type in H6, and it should bring that up. And we can double check that this is in the correct spot. But really, pin H6 is all we really need to have. So pin H6 is slide switch 2, and then slide switch 1 is H5. So I'm going to type H and then 5, and that gives me the pin. And then my rightmost bit was C, so that's going to be the rightmost switch, which is slide switch 0. And that is J6. The numbering conventions don't always go in order, so don't assume that just because one pin is H6, the next one will be 5, and the next one will be 4, because that's not always the case. So those are our pins, and then F is an output, and we're going to use an LED to signal the output. If the LED is on, the output is 1, and if the LED is off, then the output is 0. So we're going to let's see, where's our table for LEDs? We're going to use LED 0, and the G means the green LED, not the 7-segment display. We'll use that later. So I'm going to do output to the LED 0, which is pin J1. So I'm going to type J and then 1, and there we go. So we've got that pin going there. And just double check we got this right. Yep, so we've got 0, 1, and 2. Alright, so now that we've got the pin assignments done, we can actually just close this tab. There's nothing to save. If we go back to our schematic, we should see the pins labeled now on our inputs and outputs. And a very common mistake is to try to load this program to the board at this point. We need to compile again. So we're going to click compile. And what it needs to do now is assign those pins to the inputs and outputs. So we're going to compile this second time here. And we have one less warning. So the warning about the inputs and outputs not being assigned is gone. The other warnings are not important. And we should be ready to load that onto the board. So what we're going to do now is we're going to go to Tools, Programmer. We're going to make sure that our board is in the run mode. So this switch over here in the corner that says Program and Run, you're going to make sure the switch is in the run mode. You're going to make sure that the board is connected through USB and power. And you need to do that before you open the programmer. Once that's all set, you're going to select your program. It may say no hardware up here. You're going to select setup. You should see your device listed down here in a table, and you can select it with this drop-down menu here. It's a little confusing because it's listed here. You can't click it. You click up here, and you should be able to select it. It'll say something like USB Blaster. You'll select that, click close, then it should say USB Blaster. This will be selected. Mode is JTAG. And then you should be able to click Start. It's going to load your circuit onto the FPGA so that the FPGA, the field programmable gate array, is going to be rewired so that it behaves like the circuit you designed. And then you're going to test it in the real world by flipping the switches to all the combinations and making sure that the light only goes on when the input is 0, 1, 0 or 1, 1, 1. That process is the process that you'll follow for all the labs. You'll start with Boolean Algebra techniques to design an expression for a desired circuit. You will design that circuit in Quartus, do a functional simulation of the circuit, and then once you've verified that your circuit is functioning properly, you will assign pins, load it onto the FPGA, and test it in real life as well to make sure that it works outside of the simulation in the same way. And that is the entire process.